Welcome back. Edward the MetaTutor here again to talk about data types and variables in Python. This is part 2 of a 2-part video. In the first part of the video, we talked more about different data types in Python, especially the 3 big ones, integer, boolean, and string, that most beginning users need to learn and be comfortable using. And we talked about 2 functions. I want to talk about color coding briefly. If I type print here or in the shell, notice how it gives me that bright blue color coding. Same for input. That's because these are built-in functions, meaning that Python wrote the code for these. Whoever makes Python wrote the code for these, and if I type them like that, they work. I can write the code. I can use them. I don't need to write the code to make print work myself. So that's what is meant by built-in, and that is in contradistinction to a user-defined function, which is something that we will get into in a later video. That's already up on my channel. So we've already covered print and input, the basic idea being that if you have a variable, let's say a equals 3, and then you print it, if you put that as the argument for print, then it will create a new line, output that variable, and then bring you back to the shell. For input, we can catch the user input, something like that, and then print it. Cool. We can also do that in one line. Boom. But it gets a little bit more complicated than that. So for instance, let's say that I'm going to use my basic variable, just a. I'm going to say a is equal to the input, and I'm actually going to do something different here. So notice how print can accept arguments or parameters. Print can accept, if I type in a string, it'll print it out. Input can also accept a string. So I can say a equals input, and it accepts a prompt. So I can say enter a number. And now it will print enter a number, and then I put my number right there. So let's say I enter 5. Great. So now a should be equal to 5. But let's say I do a plus 3, I get an error. I like to focus on errors when I teach because students encounter errors. That's what happens. All programmers encounter errors, and you need to know how to read them. So this is a type error, meaning that something has gone wrong with the typing of my variable, most likely, or of the data I tried to add it to. So 3 is an integer, and a is, well, we don't know. In a lot of other programming languages, you have to actually define it. You have to say this is string a, int a, whatever. But in Python, you don't, and that can be a little bit confusing. So right now it's saying can only concatenate string, not int, to string. So what it's trying to do, concatenate is the term that we use when we're trying to add strings to strings. There are no strings here unless, input gives us something of type string. Exactly. So what it's thinking is it's thinking that I'm trying to add to my string here, 5, the number 3. Let's say that's what I was trying to do. Well, there's a way to do that. And it's using this function right here, the string function. So let's say I have a, which is a string. Granted, if I print a, right, it prints 5. That's literally a number, but it's treating it like a string. For instance, let me prove that to you. If I type 5 times 3, up above I just had 5 plus 3, or a plus 3 here. Let me do a times 3. Up above, it's going to say, oh, well, we can't concatenate it. But here, it's going to print 5 3 times, not 15. 5, 5, 5. Because you can do something like this in Python. You can do strings times 3, and it'll print it 3 times. So it's printing 5, 5, 5, not 15. OK, so let's say, take a step back. Let's say I wanted to turn 3 into a string. OK, fine. Well, the way I would do that is I would do this. I would say print. I don't need the print, but I want to. And I would do a plus, and then you put the string in front of it, the str keyword. Like that. And what that does is that takes 3, and even though it's a number, it treats it like a string. It treats it like it's some text. And so it treats it like the numeral 3, and it treats a like the numeral 5, which we already know that it's doing. We already know that when we input a number, that it treated it like a string. That was the error in the beginning. And so now it's going to treat them both like strings and concatenate them, add them together. And that's why we get 53. But if we wanted to do actual math, then we would have to turn a into an integer instead of 3 to a string. So let's do that. So int a plus 3. Now it's going to give us 8. So there you are. The basic idea of both of these functions is that you can expect, or you can turn data into another type by a process called casting, which is using a function like int, string, or boolean that's a built-in provided by Python. So, let's say that your user is going to, you know that you're going to expect your user to input a number, but you want to do something funny, right? Where you want to, instead of accepting the number as though it were a number and adding it to another number, you want to slap it at the end of a string of numbers. Okay, well, then what you do is instead of, you could force, instead of saying int input, which would accept, the number as an integer that you could then add, you'd accept it as a string. Now, input already accepts it as a string, but just, for the sake of example, this way, no matter what we get from it, from the input, it's going to treat it like a string, not an integer. And that would allow us to do, for instance, if they enter 9, then what we would do is we would just print a times 3. We want 999. Enter a number. Let's do something more interesting. 42. 42, 42, 42. Boom. And if I change that to int, so now it's forcing whatever input to be an integer, then it's going to print the actual numerical value there, whatever that value is times 3. So let's do something that's sort of straightforward, like 5. It should return 15. Boom. Straightforward. So Boolean works the same way. If somebody enters like true as text, instead of treating that like a string that says the word true, I can, whoops, I said enter a number still, but if I type in true, it's now going to treat it like the actual true, like the Boolean true. And so this is a way of shaping your input to look a very certain way, but it's very important, for instance, in like creating menus that are based on numbers. So let's say that, to actually make the example I want to, we said, all right, welcome to our game, print, maybe press 1 to play, and press 2 to exit. So if we combine this with some if and else statements, which are covered in another video, then you can now compare these and you can say like, okay, yeah, so if user input, which is A, is equal to 1, then print, yay, start the game, or actually run the code, which starts the game. But we're going to use a print for now, and that should work just on its own right there. It's going to ask me to enter a number. I hit 1. Boom, yay, start the game. But here's the thing. It's checking to see if a is equal to 1. If I put a string there, obviously it's going to mess it up. But if I don't put anything there, if I don't put the int on the outside of input, then what it's going to do is it's going to keep it as a string. And here's the thing. Now it doesn't work. Enter number 1, but I entered 1. Yes, but I didn't enter 1 in quotes like that. This is a string. This is a number. So that's the number, or the integer, and this is the string. So now it will work. But that's a weird thing to do because, okay, well, why ask for a number if you're not going to treat it like an integer, right? So now it is working. At that point, you might as well just say, all right, well, if a equals yes, right? And then say, type yes to play and 2 to exit, right? You might as well treat it like strings instead of like integers at that point. Yay, starting the game. Cool. So that's a basic introduction to accepting user input and how to convert that user input either into an integer using the int function, a string using the str function, and a boolean using the bool function. I hope that that's helpful. And I hope that you have learned something from the possible errors, but also bugs that you can encounter. For instance, comparing user input to the number 1 if it's accepting a string. even though the number is literally 1.